So we will work on this cost numbers basically through an example. An example is here. So we have a finished good that needs to be shipped from a plant to a warehouse at some distance away. Over a year time period, we are going to ship 1.2 million pounds of this product, right? The product costs $25 per pound, and inventory carrying rate is 30% per year. Right? We can ship this product using one of three mode of transportation available to us. We can use rail, and if we use rail, it costs 11 cents to ship a product from plant to the warehouse, but it takes 25 days, right? And when we use the rail, we have to ship 100,000 pounds together, right? Similarly, if we do the truck, transportation cost goes up to 20 cents, but the in-transit time goes down by 50%, and I can ship 40,000 units together. And finally, when I do the air, the transportation cost is much higher, but it is the next day delivery, right? And I can ship 16,000 units together. So what we are going to do is, as we just discussed, we are going to calculate the total cost of rail, truck, and air transportation, looking at the transportation, in-transit, inventory cost at destination, and origin facilities. So let me go back to here and kind of draw this figure for us. So I have an origin destination, it is called plant, and a destination which is a warehouse. I'm going to ship product from here to there. Right. The total demand is, or total amount of product that I'm going to ship is 1.2 million pound of this product. The cost of each item is 25, or each pound is $25 per pound. And inventory holding rate is 30% per year, right? This demand is also per year as well, right? So the numbers I'm going to calculate are inventory cost at the plant, inventory cost at the destination, and while it is moving, I'm going to calculate the transportation cost. Let's see. And in transit inventory cost. Right. So I'm going to calculate those four numbers. And I will do this one couple of times because I need to do it for rail, truck, and air transportation and see which one of them will have the least cost. Right. So let's do that calculation, and I will start with the inventory holding or rail. Let's put that one first, and then inventory cost at plant. You guys by now know that inventory cost is basically I times C times Q over 2 plus the safety stock, right? We have done this calculation many times. So when you do this calculation, you need to read and see if that piece of information is given. In this example that I'm showing you is there is a shipment size. What is the shipment size? Q, right? The amount I'm shipping. But there is no information about the safety stock. So I'm just going to assume that that is 0, right, for this exercise. And in the other examples, you might have that information as well. So you are going to include the safety stock and do the calculation that way. Right. Let's do the calculation for rail. it is 0.3 times 25 times 100,000 pound divided by 2 plus 0, and I don't need to even write that 0, there is no nothing over there. Okay. So what is the inventory cost at the plant? $375,000 per year, right? Next, I have to ship this item to the destination or warehouse. So I'm going to say transportation cost. Right. Here is a question. If I have to pay 11 cents per pound, that was in the problem, right? When I used the rail, 11 cents per pound. If I ship 10 pounds, how much money I have to pay? $1.10, right? What we did is basically we multiply the amount I'm shipping with the rate given. So that is our formula. R times the rate times the D. I'm saying D, the demand, because at the end of that year, each and every unit needs to be shipped from the plant to the warehouse. They are going to be shipped at the end of the year, right? Perhaps not together, but I have to ship them. Right? So again, I have to go there, and here's my R times D. R is the transportation per unit, right? In this unit, or in this problem, the unit is per pound, basically, or pound. Demand is there. Right? So my transportation cost for rail is 11 cents times 1.2 million pound. And you guys will tell me what is that result. $132,000 per year. Right? That's the amount I have to pay. Next one is the in-transit inventory cost. Right? You guys remember we had a lot of examples like if my inventory holding rate is 20% and the product value is $100, if I keep that product for a year, I will be paying $20 as an inventory holding cost, right? You guys remember that one? So 20 times 0.2 times 100. Now think about that time frame not being a year but only 2 weeks or 10 days, right? What I need to do is calculate the cost for whatever the year and then look into what percentage of year or week is this item on the move, right? And the formula becomes something like this. Let me write first and then we talk a little bit more. I times C, that is again the inventory holding cost, D times T divided by 365, right? Here, T is lead time, in transit time, whatever the question is saying, basically the shipment time from origin to destination, right? Depending on different books, you might have different things, right? What is this T over 365? That is basically, I know that this I is in year at this point. Remember in my example it was 30% per year. So what I'm saying is the transportation time, the in-transit time is 25 days. So 25 days is how many years, right? 25 divided by 365 basically tells me how long in a year I'm keeping this item on the move, right? Basically, I'm just making them time consistent in terms of calculation. So 20%, 100, that is your $20 as if I'm shipping a single item. So if I'm shipping one item, that is 100. If it is two, then it is 200. In this case, again, I'm going to ship that 1.2 million pound from warehouse, plant to the warehouse. So each one of them will spend 25 days on the move. And then T over 365. If my in-transit times was in weeks, or let's go with the month. What would I do if it was in months? T divided by 12, because that would basically convert to a month. Or I could do ICDT by 52 to just again convert and make them time consistent, right? So only thing I'm worried about is whether this I and T are time consistent. If they are not, I'm just making sure that they are time consistent. Right? Any question about making that unit time consistent? You have done so many times, I'm sure you know right now, but it doesn't hurt to emphasize. All right. In this question, it is 25 days basically the transit time. So when I ship this product with rail, it takes 25 days to travel from the plant to the warehouse. And within that time frame, it is part of my inventory. Right? Because it is on the move, we call it in-transit inventory as a special name. Right? So let's do this calculation. What was I, guys? I totally forgot about it. 0.3. All right.
In this scenario, we're all doing this by rail, right?
Yes. Right. So I'm going to do the same calculations for the others as well. I is 0.3, C is 25, D is 1.2 million, T is 25, and dividing that 25 by 365 gives me basically how many year is that amount, right? What is the 25 divided by 365, by the way? Can somebody do it?
0.086.
So basically, in 1.086 year, that product is part of my in-transit inventory, and I'm sharing that $7.5, which is the multiplication of these over that period of time. So what is the result? $438. Okay, it's like $616,438 per year. Right. Let's leave it as it is. I think it's like 38 cents or something, right? All right. So that is the in-transit inventory cost. It might be interesting to see that in-transit inventory cost is higher than the transportation cost itself, right? Sometimes we are worried about the transportation cost so much, you may miss that there might be another cost impacting more, right? The last thing is inventory cost at destination. In this case, it's a warehouse, right? Now, of course, the formula is still valid. I times C times Q, in parentheses, Q over 2 plus the SS. But something happens in this calculation to the C, right? For example, early in the semester, we discussed when we are buying the product from eBay, we don't only look into the sales price, we also look at the transportation cost, right? So let's say you buy a product for $25, and then pay $5 for the transportation. What is the cost of the product for you? 30, right? 25 plus 5. So when you ship product from this factory to a plant, when the product arrives at the warehouse, from plant to warehouse, the product is not $25 product anymore, because I also paid for the transportation. Now it is a new value. I'm going to call it, let's say, C prime, and C prime is C plus the rate. So basically how much I pay for the transportation cost, right? So I update the cost of the product and then use the same formula, right? And my formula is kind of saying C prime, but it is the C basic, the value of the product. Right? So my inventory cost at the warehouse, okay, let me do this one. For 25 plus 11 cents. So 25.11. So when the product arrives at the warehouse, it is not a $25 product anymore. It is the $25.11 product. Right? So let's do the math now. 0.3 times 25.11 times, in parentheses, 100,000 divided by 2. I'm not going to even include that safety stock zeros over there anymore. So what is the result? $376,650 dollars per year. Right. So if I choose train as the mode of transportation, my total cost is going to be inventory at both location plus the in-transit plus the transportation cost itself. So my total cost rail is, I think we started with $375,000. That was the inventory holding cost. Then 132 as the transportation cost. Then what was it? 616. You guys gotta help me. 438. 8 as an in-transit cost plus 376.650 as the inventory holding cost as the destination. So what is the total cost of rail? Okay, dollars per year. So that is gonna be the cost of shipping this product from plant to warehouse over a year time period. This is 1.5, by the way. Any question? Now you would understand why doing this by hand is not a fun thing. We are gonna do all calculations for the other two. Right? So if you do set up the Excel, it is really easy, right? You just plug in the formula, and now we have to do it by hand, right? So do the truck. All right, inventory cost at plant, and when we do the truck, the quantity is 40,000 shipping quantity, so that is the new Q value basically that I'm going to use. Transit time is 13 days and the rate is 20 cents. Right, so I have to basically update my numbers using those things. Okay, one time I see, if I can erase this. You guys probably remember this one, but what I'm writing is always this, right? IC times AIL, where AIL is Q over 2 plus safety stock. Again, I'm going to assume safety stock is 0 because there is no information about it. Right? So 0.3 times 25 times 40,000 divided by 2. $50,000? 150. Right? Under $50,000 a year, that is the inventory holding cost at the plant. Next is the transportation cost, and that is R times D that we mentioned earlier, and that is gonna be 20 cents multiplied by 1.2 million pound, and that is 240. Right, again that is per year. Next is going to be inventory in transit inventory cost. And that is ICDT over 365, because I know that T, the transit time, is in days. In the problem setting, that is 0.3 times 25 times 1.2 million. The in transit time when I choose truck was 13 days, so I'm going to update with that 13 and then divide by 365. So what is the result? 320,548. Thank you, per year. Right. Next is inventory holding cost at the warehouse. Right. For that, first thing is going to be the updating the C prime value, or the new value of this product. C prime is going to be C plus R, and that is 25 plus 20 cents. Right? It becomes 25.2, and my inventory cost is IC, basically Q over 2 in this example. 0.3 times 25.2 times 40,000 divided by 2. Bless you. $151,200. Thank you. Per year. Right. And total cost truck is 150,000. That is the inventory holding cost at the plant. What was the rate? 300,000. 240, right? Transportation cost plus 320, 548 plus 151, 200. And the total cost of truck is 861. Right. So that is if I ship everything with truck. Any questions? Ready to do more one more time? Don't like it, but I have to do it. Alright, so let's do that one. This time we are going to look at the air transportation, and we will start the inventory holding cost at plant. IC Q over 2, right, plus SS, but we discussed SS is not there anymore. I believe it is 16,000 this time. Right. $60,000. Right. Next is the transportation cost. R times D, and we know R is 88 cents times 1.2 million pound. $56. Sometimes I might forget, but all these costs are in dollars, right? And in transit inventory cost, ICDT divided by 365.3 times 25 times demand is 1.2 million, and the in transit time, if we do air, it is a single day, so it is 1 divided by 365. So what's the number? 657. You know, what was the in-transit inventory cost for the rail? 616. So shipping fast helps a lot in terms of inventory holding cost, right? But we'll see which one is the lowest cost at the end. Alright, so this is per year as well. And finally, it is the inventory holding cost at the warehouse. Again, first thing I'm gonna do is get my new cost value, which is C plus R, and that is 25 plus 0.88 or 88 cents. So my C prime is $25.88. Right. Now the IC Q over 2 calculation. It's 1.3 times 25 times 25.88 times 16,000 divided by 2. So the result is so overall total cost air is gonna be sum of those four numbers. What was the first number? 62,000? 60,000 plus the next one is 1,056,000. The next one was And finally it is 62,011. Right, so the total cost air is $1,202,000. Okay. 769. Thank you. So which one we are choosing? Truck, right? Truck has the least cost option in this example. So we should go with the truck transportation. And that was 861,748 compared to 1.5 million and 1.2 million dollars.